Hey, welcome back to your favorite calculus class, you guys. Let's talk about inverse trig functions for a minute. Let's just review like let's say taking the arc sine of negative a half, right? When you did that in your trig class, you probably used the fact that this was an inverse, or at least this is one way to solve that. So the arc sine of negative a half equals theta. Since that's the inverse of the sine, that means the sine of theta would equal negative a half. Now remember, in order to create the arc sine, we had to cut off um, theta between negative pi halves and pi halves. So when I'm looking for this answer, it'll be between negative pi halves and pi halves, right? So I'm thinking to myself, where is the sine of theta on my unit circle? Right, I have my unit circle. Where's the sine? Negative a half, and hopefully you respond, well, that's at 11 pi 6, but you want the negative of that, so negative pi 6, so negative 30 degrees. The sine of negative pi 6, right, again, we're looking between angles between negative pi halves and pi halves. Sine of negative pi 6 is negative a half. So we know theta's got to be equal to negative pi halves, therefore the arc sine of negative a half equals theta, equals that negative pi 6. Again, because they're inverses, right? That's a little review of our inverse trig function. Let's go ahead and look how we're going to then use our background knowledge to be able to solve some of these here. All right, let's look at this first one now. We've got the secant of the arc tangent of 4x. What I'm going to do is I'm going to take step number one. And I should say for all these problems, we're gonna involve drawing a triangle and labeling the sides, so we can assume that x is positive, and we're gonna draw this triangle into the first quadrant, so you can assume that, you guys. But step number one, we're gonna take that arc tangent of 4x, and we're gonna set that equal to theta. And so we can say, well, if the arctangent of 4x equals theta, then we know the tangent of theta must equal 4x, right? Because they're inverses. Of course, theta would be between pi halves, negative pi halves, because that's where you cut off the tangent to create the arctangent. Again, we're assuming x is positive, so this will be in quadrant one always. Step number two now is what we're going to do is we're going to use the fact that the tangent of theta equals 4x, or 4x over 1, and we're going to draw this triangle here with theta, okay? And if you remember SOHCAHTOA, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent's opposite over adjacent. Of course, I remember that as, oh heck, another hour of algebra. That's how I remember, or that's how I was taught SOHCAHTOA. But anyways, our tangent here is opposite. The 4x part would be the opposite side. So I'm looking at the theta. Of course, my opposite side would be right there, opposite. The adjacent would be right next to it, so that would be the 1. And then I'm going to go ahead and solve for the remaining hypotenuse side. So I'm going to say, okay, well, that means 1 squared plus 4x squared equals my hypotenuse square. So I square root both sides, and I get my c would end up being the square root of 16x squared plus 1. And I'm going to go ahead and write that in. Okay, so I've labeled all sides of my triangle. Now, third step, what we're going to do is we're going to say, well, we've got the secant of the arc tangent of 4x. Now, remember, we called the arctangent of 4x, we called that theta. We called this theta. So what we're really doing with our triangle is finding the secant of theta. And you know, the secant's the reciprocal of the cosine. We know the cosine is adjacent over hypotenuse. So we know the secant would be hypotenuse over adjacent on the triangle. So I go back over to my triangle and I say, oh, my hypotenuse side is that square root of 16x squared plus 1 in red. And my adjacent side, so there's my hypotenuse, and here's my adjacent side to theta, the next two side of theta over 1. So the secant of theta, which again, theta we called the arctangent of 4x in that beginning step, must be the square root of 16x squared plus 1 all over 1. Similarly on this problem, we're going to go ahead and start with that arc sine. Arc sine x minus 1. We're going to set that equal theta. So we'll name that theta. And that means if the arc sine of x minus 1 equals theta, that means the sine of theta equals x minus 1. And of course, sine of theta is opposite over hypotenuse, right? That's what our sine is. So Coteau again. So we're going to go ahead and draw our triangle here with theta. And our opposite side we're going to call x minus 1. Our hypotenuse this time would be 1. Hypotenuse would be 1. So let's go ahead and solve for, let's call it the a side here. So a squared plus x minus 1 squared equals our c squared, our hypotenuse squared. So we've got a squared equals 1 minus, I'm going to take that x minus 1 squared to the other side. I'm going to square root that, both sides. So a equals squared, I should expand this. I get x minus 1, x minus 1. So I've got my a end up being 1 minus x squared minus x, so minus 2x plus 1. Distribute that, it looks like my 1's go away. So I've got positive 2x minus the x squared. So that's my a. Now I'm going to go ahead, let me throw that in right here for the adjacent side, which is square root of 2x minus x squared. And now step 3. Remember we were finding the cotangent of the arc sine of x minus 1, but we called that theta right there. So really we're finding the cotangent of theta. You know, the tangent's opposite over adjacent, so the cotangent would be adjacent over opposite, right? So the cotangent of theta would be the adjacent side, so that's that square root of 2x minus x squared, that's right next to the adjacent side to theta. And the opposite side is that x minus 1. Therefore, the cotangent, remember theta was the arc sine of x minus 1. This is what we were asking to find. So it would be the square root of 2x minus x squared over x minus 1. And we should know, bless you, we should know that x cannot be 1, right? Notice we can't divide by 0, so x can't be 1 either. So this will set us up for finding the derivative of an inverse here. So number 1 here, notice we have y equals the arc sine of u. Right, so the arc sine of u equals y. Well, that means then that the sine of y must equal u, right? So if we go ahead and kind of do that same approach, so I draw my triangle, sine of y here, so y is my angle here, is u, or u over 1. So here's my opposite, here's my hypotenuse, right? My opposite side would be u, my hypotenuse would be 1. I go ahead and solve for that other side, so a squared plus u squared equals 1 squared. So a squared equals the square root of 1 minus u squared. So I'm going to put that in right here, square root of 1 minus u squared, right? And then I'm on to step 3. Well, this is what I have for step 3. You know, I have the sine of y equals u, right? So let's go ahead, because what I'm trying to do is I'm trying to find the derivative of the arcsine, right? So let's go ahead and take this derivative with respect to x. And what we'll have as derivative of the sine is the cosine of y times dy dx, so times y prime, equals over here, derivative of u is 1, chain rule, u prime, right? Those derivatives do not agree there. So if I was solving for y prime, I'd say, okay, y prime, derivative of y equals u prime divided by that cosine of y. Now, what is the cosine of y? So note, the cosine of y, looking on my triangle there, that would be my adjacent over hypotenuse. So that'd be a square root of 1 minus u squared over 1. So the cosine of y is going to go in right there. Okay, so let's continue on. So y prime, by substitution, y prime equals u prime over cosine y. And I'm going to put in that cosine y, which is the square root of 1 minus u squared. Okay. So therefore we have it. Therefore, if y equals the arcsine of u, whatever u is, then y prime is 1 over the square root of 1 minus u squared times chain rule times the derivative of u, times whatever u is. So what about the arcsecant if we're finding that derivative? So let's go ahead and do the same thing. If we got this arcsecant of u equals y, then we know the secant of y equals u. You know, secant's the inverse of the cosine, right? So in other words, 1 over cosine equals u. So the cosine of y equals 1 over u. Would be the same thing. You know, cosine's adjacent over hypotenuse. Right? Or you could have just done it. This is hypotenuse over adjacent if you want to do it that way. Bless you. And so we go ahead and we'll draw that. We got our y in here, and the secant's hypotenuse over adjacent, or if you want to think adjacent over hypotenuse, cosine of y. We'll go ahead and solve for the remaining side. So 1 squared plus b squared equals u squared. So this will end up being the square root of u squared minus 1, which we solve with the Pythagorean theorem, right? Remember, this is a 90-degree angle there. And then step 3. So what do we have? We have the secant of y equals u, and we're going to go ahead and take that derivative. And so we've got secant y, tangent y. That's the derivative of the secant tangent. And then times y prime, dy dx. We don't know what y is, right? Those derivatives do not agree. And over here we got derivative u is 1, but du dx, so u prime here. And so y prime is u prime over secant y tangent y. Now note our secant, so by substitution, our secant of y here is u over 1, right? Hypotenuse over adjacent, we knew that. And our tangent of y, again, I'm looking at my triangle, that would be opposite over the adjacent, which is just the 1. So when I make that replacement, so by substitution, y prime ends up being, I got u prime over secant y, which is just a u. And then the tangent of y is the square root of u squared minus 1. So there's my y prime. I like to think about as 1 over u square root of u squared minus 1 times chain rule. u prime. And that's the derivative of the arc secant of u. Well, we won't do all of them, but here's the rest of those rules for the derivatives of inverse trig functions. So let's go ahead and start using the rules with this example here, the secant of 2x. So y equals the secant, arc secant, sorry, of 2x. So our dy dx, our y prime equals. So the derivative of the secants, 1 over u, absolute value of 2, if you want, or 1 over absolute value of u, square root of u squared minus 1, I'm using this one right there, times u prime is on the top, right? What's the derivative? What's the derivative of 2x? Just a 2. And so y prime ends up being 2 over, now the absolute value of a times b is absolute value of a times the absolute value of b. So if you look at that absolute value of 2x, I've got absolute value of 2, which is 2, absolute value of x, 2x squared, quantity squared would be 4x squared minus 1. So notice those 2's cancel right there. And so we're just left with y prime being 1 over that absolute value of x squared of 4x squared minus 1 there to the 4th. So this next one we got the arc cosine. So I'm using the rule that the derivative of the arc cosine of u is -1 over the square root of 1 minus u squared times chain rule. That just reminds me that I got the chain rule, right? And so if I use that, my u, of course, is 5x to the 4th. So this derivative, y prime, would be -1 over square root of 1 minus u squared, so 5x to the 4th squared, times derivative of 5x to the 4th, which is 20x to the 3rd. And of course, I can multiply -1 and 20x to the 3rd. I get -20x to the 3rd over the square root of 1 minus 25x to the 8th. And there's my derivative on that one. So this next one, I'm using the rule that the derivative of the arc cotangent of u is 1 over 1 plus u squared. Oops, I'm sorry, that's -1 over 1 plus u squared times u prime. Chain rule on that. That's the derivative of the arc cotangent. And so let's run it now. Of course, my u is at 3x squared minus 8. So I got -1 over 1 plus 3x squared minus 8 squared times chain rule. Derivative of 3x squared minus 8, 6x minus 0. So this just ends up being -1 times 6x just ends up being -6x. 1 plus, I should expand this, so that'll be 9x to the 4th minus 24x squared minus another 24x squared, first outer inner last, and then a plus 64. And so my y prime ends up being -6x over 9x to the 4th. Oops, that should be minus 48. Sorry about that. So minus 24, minus 24 on that. Minus 48x squared, and then 1 plus 64 is 65 there. This next one would be a wonderful, make this a u-try problem. Go ahead and you can stop the video. You're taking the derivative of the arc tangent of u, and the derivative of the arc tangent is 1 over 1 plus u squared times u prime, chain rule. Well, there's the 1 over 1 plus u squared. You notice the square will undo that square root. So 1 plus 5 minus 2x. And then over here, notice those 2's cancel. It does leave you with that -1 though. So we got negative times -1 over square root of 5 minus 2x. And so we've got y prime ends up being a negative 1 over 1 plus 5, I got 6 minus 2x being multiplied by the square root of 5 minus 2x on that. Here we've got a natural log on this. So we're going to have to run the derivative of the natural log. Derivative of the natural log is 1 over that. So we took the derivative of the natural log. Now we got to run the derivative chain rule. What's the derivative of the arc cotangent? So I'm using the fact that the derivative of the arc cotangent of u is negative 1 over 1 plus u squared times chain rule derivative of u. And so we've got times negative 1 over 1 plus u squared times derivative of u. Well, what's the derivative of 2x cubed? 6x squared. And so y prime ends up being negative 6x squared over the arc cotangent of 2x cubed times 1 plus 4x to the 6th. This would be a good U-try problem if you guys want to pause the video here. Let's go ahead and take the derivative. Notice I have a product here. So derivative of the x, derivative of the first times the second plus the first, and then I'm taking the derivative of the arc tangent. Well, the derivative of the arc tangent is 1 over 1 plus u squared times u prime. So when I take the derivative of the arc tangent of 2x, it's 1 over 1 plus 2x squared times derivative of 2x, which is just 2. And then we got minus the constant. Derivative of the natural log is 1 over that. But then we got to take the derivative of that 1 plus 4x squared, which is 0 plus 8x. And so let's go ahead and clean this up. We've got the arc tangent of 2x. I've got a plus 2x over 1 plus 4x squared. I've got a minus 8x over 4 times 1 plus 4x squared. But notice 8 over 4 right there is 2. So I got 2x over 1 plus 4x squared minus 2x over 1 plus 4x squared. So those are like terms, those are gone. And we just have our y prime, and just ends up being the arc tangent of 2x here. All right, last one here we've got, we're going to have to know the derivative of the arc sine of u, which is 1 over the square root of 1 minus u squared times u prime. So y prime ends up being, the constant will stay there, derivative of the arc sine is 1 over square root of 1 minus u squared times derivative of u. So what's the derivative of 1/5 x? It's just times 1/5. And then minus, and now I've got a product rule here. So I got to put this all in parentheses when I take the derivative of the first times the second plus the first derivative of the second. So that's 1/2 25 minus x squared to the 1/2 minus 1, so negative 1/2 times that chain rule, negative 2x derivative inside there. And so it looks like we've got 25 times 1/5, so I've got 5 over the square root of 1 minus x squared over 25, and then minus, looks like I've got square root of 25 minus x squared, and then it looks like I got a negative 2 over 2, so I've got a negative minus an x squared over square root of 25 minus x squared. I'll go ahead and distribute that now. I'm going to get a common denominator here. That's over 1. So I'm going to give this a square root of 25 minus x squared, square root of 25 minus x squared. That'll undo that radical there. So I've got, this will become 25 minus x squared, and then plus x squared. This is all over that common denominator, square root of 25 minus x squared. And I'm going to go also over here, I'm going to write this as 1 over 1 minus x squared over 25. So that's 25, if I give that a common denominator, over 25. And then minus, and I've got 25 minus x squared plus 25, right? So I've got 25 how am I going to write this? Let me go. Sorry, let me keep this split for a minute so you don't distribute that minus everything there. So see how that minus will go to both of those. So I've got a negative 25 plus x squared all over the square root of 25 minus x squared. And then over here I've got 5 over square root of the top, square root of 25 on the bottom is just a 5. So I'm going to multiply that by its reciprocal. And I've got this stuff over here. So this y prime, once I multiply by the reciprocal, I'll have 25 over the square root of 25 minus x squared plus negative 25 plus 2 of those x squareds all over the square root of 25 minus 25, minus x squared. Now they're all over that common denominator, so I got 25 minus 25, those will be gone. I'll just left with 2x squared over the square root of 25 minus x squared. And that's it for taking notes on derivatives of inverse trig functions. We'll see you next time.